All right. So today we're going to continue with chapter 3. So we have seen what is the impulse and what is momentum in our previous lesson. Today we're going to see how to solve questions related to impulse and momentum. So for exercise 1, we are going to solve a simple questions that just apply the definitions of momentum and impulse, which is P equals to mv. M So P equals to mv, and then J equals to ft, as well as the theorem that connect the two of them together, which is the impulse momentum theorem. So let's see the first question. First question is the most basic, most simple questions that can be found in the exam. So they give you two pieces of information, which is a 750 kg car, and then has a speed, which is v, and it's asking for momentum. So apparently this is a very simple question, and in exam, this type of question it worth only 1 marks. Okay, if you have a very simple questions, which applies just one equations, and then all information is given. For example, like this. So this one, because you have just P equals to mv, you don't need to know the directions, you don't need to know any other things. So it's just a one simple substitution. So this is a 1 marks question. So P equals to mv equals to a 750 times 10. Therefore, you have 7500 kgms negative 1. So questions 1 is just a very simple questions. Now let's look at questions 2. Questions 2, a skater of mass 80 kg. Now again, you have the keywords initially at rest. So what does it mean? It means your initial velocity u is equals to 0 ms negative 1. And it's speed up to a final speed, okay, final speed of 10 meter per second. So this is your v, along a straight line towards the east direction. So find the momentum of the skater while it is at rest. So you want initial momentum. So P initial. P initial, of course, you're going to use initial velocity. And according to the question, initially the object is at rest. So mu is equals to u is equals to 0. Therefore, P is also equals to 0. So 0 kg, yeah, 0 kg ms negative 1. So this is your questions A. So a very simple questions. Now questions B. Find the momentum of the skater while it is traveling at its final speed. Final speed means it's asking for V now. So so you want P final. So P final is equals to M. Of course, you're going to use final speed, mv, which is then equals to 80 kg times 10 meter per second. It is equals to 800 kg ms negative 1. So what is the direction? Now momentum is a vector, so don't forget about the direction. So to the east, okay, towards east direction. Towards east. So we know it is towards east because because question tells you initially it's moving towards the east direction. And then find the change in the momentum. Now, whenever you have the term change, what does it mean? It means final minus initial. Okay, the terms change carries a meaning final minus initial. So now that you have a final momentum in your questions B and then initial momentum in your questions A, therefore delta P, okay, change is a delta, so del P is equals to P final minus P initial, which is 800 minus 0, so final answer is still 800. So 800 kgms negative 1. Right. So when you write it, make sure to leave some space in between every unit, all right, to indicate that this is unique. Otherwise, if you write them close to each other, then M, sometimes people might misunderstood it as the uh, milli. Okay, for example, in questions number 3. So if you look at questions number 3, A system is made up of two objects. So now what do you have? You have two objects. Okay, so one object, the mass is 1.5 kg. Now the keyword is it moved to the right at a speed of 10 meters per second. The other object of mass 2 kg is moving to the left. Now you have two objects moving towards different direction. And if you notice, the unit given is in ms negative 1. So what does it mean by this ms negative 1? Now in exam or in a questions, in any test, if there's no space between m and s, then this m it carries meaning milli. Okay, so what does it mean by milli? It is equals to times 10 to the power of negative 3. All right. So this 10 ms negative 1, it means 10 milli per second. Okay, 10 meter. Oh no, sorry, that's my bad. So this question is a meter per second. So that is the typo in your text. All right, next questions is a time in millisecond. So if there's no space, usually we will interpret it as millisecond. All right, so this question, okay, there is a typo. There should be a space between them. So right, let's see. So now you have two objects. So I'm going to call object 1 as an object. I'm going to call it object A. Okay, the other object, I'm going to call it object B. So object A and object B. So I'm going to list down the informations for each of them first. MA equals to 1.5 kg. So MB equals to 2 kg. All right, and then VA now. VA, it tells you object is moving to the right. So VA is positive 10 meter per second. And then VB is to the left. So negative, you need to include the negative. All right, negative 12 meter per second. Okay, now if you look at the question is asking for total momentum. So total momentum is different than the change in momentum. Change, we use final minus initial. Total, we are going to add all of the momentum together. So now we have two momentum. Okay, we use PA plus PB. If change, just now same object, you have only one object, but then you use final minus initial. So that is the difference between change in momentum and also the total momentum of the system. All right. So total momentum summations P. So summations P equals to PA plus PB, okay, which is then equals to MA VA plus MB VB. All right. Therefore, what do you have? You have a MA, which is 1.5, and then a 10 meter per second plus 2 kg, and then negative 12. You need to include a negative sign, okay, because the V in your equation is actually a vector. So you need to include negative sign, and therefore the final answer is negative 9.0 kg ms negative 1. Okay, now, whenever you have a value with a negative sign, I would recommend you to rewrite the answer in a statement form. Why? Because sometimes some lecturers will argue negative already represents the direction, then you don't need to write directions at the end. But some they will say you still need to write direction, but then you need a positive value. Okay, because if a negative means to the left, if you write to the left at the back, negative and to the left means that it is a positive direction. All right. So I would encourage my students to write it in a sentence form, in a statement form, to avoid all those possible argument. So you just write total momentum. Okay, total momentum is, now you write a value without negative sign. So total momentum is 9 kg ms negative 1 to the left. Okay, to the left. So this can avoid all sort of argument. So whether you need to include a negative sign in your answer or not, whether you should put a directions again after you have a negative value or not. All right, it's because all those things is quite a common argument amongst the lecturer. So I don't know who is going to mark your exam paper. So in order to be safe, it would be better if you write it in a sentence form. Okay, because every lecturers they marks in their according to their own way, own method. So we try to avoid all those possible argument to make sure you can score full marks in the exam. So negative, whenever you have a negative value, negative vector, you rewrite it in a sentence form. If you have a negative scalar, then you leave it. Scalar quantity, no argument. But when it comes to vector quantity, then there's a lot of argument. All right. So when you have a negative value, we write in a sentence form, and it is also to prevent some of the possible argument. Why? Okay, because sometimes question will ask for magnitude. So if the question is asking for magnitude and you are calculating a vector, then the final answer must be a value without negative sign. That is magnitude. So this one is what we call magnitude. All right. So sometimes if you overlook the questions, you leave the answer in the negative form and question is asking for magnitude, 1 mark will be deducted. But if you rewrite it in a statement form, okay, and you have a positive value in your statement, then you are going to get a full marks in the exam. Okay. So whenever you have a negative value, remember, change it into a sentence. Okay, make it into a sentence. All right. So next questions. Questions number 4. Figure shows two objects, A and B, moving on the XY plane. The masses of A and B are 1.5 kg and 2 kg respectively. Determine the magnitude and the directions of the resultant momentum of the two objects. So what are we going to do? Now you have two object with two different vector. Uh, they are not lying on the same plane that can let you calculate, right? So what we can do, if you remember what we did in our chapter 1, we construct an xy plane, the coordinate plane, okay, the Cartesian coordinate, and then we move the vector. So now what am I going to do? I'm going to move this vector, the blue color vector, so I color it. This blue color vector, I'm going to move it. I take this whole vector, I move it to my new Cartesian coordinate. So this is my vector A, okay, that is moving with an velocity v a equals to 3 meter per second. All right. And then for this, okay, I'm going to color it as a green. Okay, so this green color vector, what am I going to do now? I'm going to move it again. I take this green color vector out. I then place it in my new Cartesian coordinate. Okay, so now what do I have? I have this VB, which is equals to 5 meter per second. Okay, which is equals to 5 meter per second. All right. So yeah. So what do I have right now? So now I have a new Cartesian coordinate where my A is going to the direction. What happens? Okay, so yeah, it's going nuts again. Right. Okay, so now I have a new Cartesian coordinate which shows the directions of the velocity. Okay, velocity A now is located 30 degree above horizontal. So I have this 30 degree above horizontal, and then I have a VB. So VB is 5 meter per second. Now, why is it so important to know how to construct a new Cartesian coordinate? Okay, in the XY coordinate. Because if you recall, I keep telling you guys that the momentum is a vector. All right. Now, these two vector, okay, momentum is a vector, and the momentum, it follow the directions of velocity. And if you look at the diagram given, now these two vector, they are moving towards different direction. Therefore, you cannot simply add them up. What you can do, you need to resolve them. So how are you going to resolve them? Now let us construct a table as usual. Okay, so let us construct a table. Construct a table. So this is my table. Okay, so I'm going to construct a bigger table because you need to do a lot of calculation in it. Okay, so this is my table. And then I have an X component. I have a Y component. And then this is my PA, momentum for object A. And then this is my PB, momentum for object B. And then this would be a total. Okay, the total momentum. So the summation. So what am I going to do now? I'm going to calculate the momentum one by one. So if you know, okay, if you notice, P is equals to mv, right? So what does it mean? It means if you're going to calculate px, then you have to use mvx. If you're going to calculate py, then you need to use mvy. So m, you don't need to resolve it, but you resolve in terms of x. So now for PAX, PA along x component, it is equals to MVA, but A is along x component. All right. So therefore, it is equals to, so what is the mass for object A? Object A is 1.5. So I have a 1.5 kg. Okay, 1.5 kg. Now, what is the values of VA? VA is 3 meter per second. So 3, now 30 degree is above horizontal component. Therefore, for x component, 3 cos 30 degree. Okay, 3 cos 30 degree. So if you calculate it correctly, what are you going to get? You're going to get a value that is equals to, let me see what is the value. So if you calculate it correctly, you're going to get 3.9. Okay, 3.9 kg ms negative 1. So this is for PAX. So AX, AX. So you resolve velocity. Okay, you resolve velocity. So for PAY, then it is equals to MVAY. Okay, MVAY, which is then equals to 1.5, but V now is 3 sine 30 degree. Right? So the final answer is 2.25 kg ms negative 1. So that is for component object A. Okay, the momentum for object A. Now let's see how are we going to do for object B. So object B, you want to calculate PAB. PAB pula. PBX. Okay, PBX. So PBX equals to MB. Okay, so VBX. So which is then equals to 2 kg times, okay, now this 5 is lying on the x component. Therefore, for PB, it's very simple. Straight away, VBX is equals to 5. Okay, because your BX is lying on the x component, therefore straight away equals to your VBX. So 10 kg ms negative 1. So what happens to the y component then? So there's no velocity along y component. Therefore, you don't even have to calculate. Okay, so you just calculate PBY equals to 0 kg ms negative 1. So that is how you solve it. Okay, that is how you solve it. You resolve velocity in your calculation. So AY, you use VAY. Okay, so for a BX, we use VBX. AX, you use VAX. Done. So now that you have all of them, yes.
Kalau macam yang B tu,
Mm-hmm.
kalau B naik ke atas, maksudnya dia punya X kosong lah.
Ya, betul.
Okay.
Kalau velocity hanya ke atas, dia tak ke kanan atau ke kiri, then X dia kosong.
Okay.
Okay, so now that you have all these value, and according to the diagram, all of them, they are located in the first quadrant. So they are all positive value. Okay, they are all positive value. So you can just add them up. So total Px, okay, now you calculate total momentum along x component. It is equals to 13.9 kg ms negative 1. And then Py, okay, summations Py. So now this is not A or B anymore. This is the total along y component. It is equals to 2.25 kg ms negative 1. So this is the total along x component and total along y component. So now that you have x and y component, you can then answer the question, which is the resultant of the momentum. So resultant, if you recall what I've learned in a previous chapter, so P resultant, okay, equals to square root bracket summations Px square plus summations Py square. Okay, so therefore square root, you have a 13.91 square plus 2.25 square, which is then equals to, let me see, the final answer is 14.08. 14.08 kg ms negative 1. So this is your P resultant. And of course, again, don't forget that P is a momentum, which means you need to calculate its direction. So theta equals to tangent negative 1, open bracket. So summations Py over summations Px. So close the modulus. Therefore, you're going to obtain an angle 9.19 degree. So how do I know which quadrant it is? Again, let us go back to the table. So according to the table, we have a Px and Py. Both of them, they are in a positive value. So positive x, positive y, it means our resultant vector is in the first quadrant. So first quadrant, how do we describe it? Above, okay, above what? Above positive axis. So that is how we describe it. All right, by looking at the table, by checking with the table. So table say positive and positive, therefore I know it's located in the first quadrant. Right, so these questions, I will give you 2 minutes to write it down because it involves a 2-dimension questions. Okay, it's a 2D question. So I give you 2 minutes to write it down. Okay, and of course you have an alternative method. All right, you have an alternative method. So what is the alternative method? So I will show you alternative method as well. Okay, so let's see. How are we going to use alternative method? Now, sometimes you don't have to resolve it in a table. Some students, they will calculate PA first. They calculate PA by using MAVA, and then they calculate PB by using MVVB. And then after they obtain A and B, they then construct the table. All right, and then what are they going to do? In their table, okay, they resolve P instead of V. So still PA, PB, still X component, Y component. But then what you can do is now you use PA cos 30 degree and then PA sine 30 degree. Here you straight away put PB and then this is 0. All right, you can also do like this. It's fine. So both of them, they are correct. So you calculate summation. So you go back to summations Px, summations Py. All right, so you have 2 methods. You can write down both of them. So 2 minutes from now for you to write it down. So it's up to you which one you want to use. All right, yang mana satu kamu rasa lagi senang nak faham, then kamu gunalah kaedah yang tersebut.
Madam,
Yes?
yang macam yang dia bagi tu kan,
Aha.
yang 0 tu memang dia fix ke?
Yang mana satu?
Yang 0 sebelah.
Untuk Y
0
component.
on Y, yes.
Well, because you have nothing along the Y component, right? So even after you calculate PA and PB, what you have right now is exactly same as the first Cartesian coordinate. Sama macam yang ini. Cuma sekarang V kamu tukar menjadi P. So what you have here is just like This is your PA, and then this is your PB. So PB is still lying on the x component, right? Therefore, your PBY is equals to 0.
Oh, okay.
So, all right, any other questions? Because you need to understand this before we proceed to exercise 3, conservations of linear momentum. In conservations of linear momentum, we have the questions in a 2-dimension, all right, and you need to know how to resolve them. And in that, in a exercise 3, you're not going to resolve only for a 2 object. You need to resolve before and after collision, right? So right now we're looking at the fundamental things. We're looking at the basic thing. So if you have any questions, you better ask now. Okay. Next. So next, what are we going to see? Questions 5. Okay. So questions 5. Let me change color. So questions 5 is now a questions involve impulse. Okay, it's a questions for impulse. So what are we going to calculate? A tennis ball, a 0.2 kg tennis ball, strikes the wall horizontally with a speed of 100 meter per second, and it then bounces off with a speed in the opposite direction. Okay, so now you have a velocity, a speed that is moving in the opposite direction, which means in your calculation, there must be a negative value. All right. So let us sketch a diagram first. So usually I like to assume my object is moving to the right. Therefore, now I'm going to assume the wall is on the right hand side. Okay. So I have a tennis ball. So it's moving horizontally with an initial velocity 100 meter per second. Okay, it hits the wall and then it then bounces off in the opposite direction. Therefore, the V is equals to negative 70 meter per second. Right. So calculate the magnitudes of impulse delivers to the ball by the wall. So you want to calculate the impulse on the ball. Okay, you want to calculate the impulse on the ball. So why is it important to know whether the impulse is acting on the ball or on the wall? Because it will affect our sign. I will show you after this. Right now, let us start our calculation first. So calculate the magnitudes of impulse. Now, what do you have? You have initial velocity, you have final velocity. So apparently, you cannot use the definitions of impulse, which is J equals to Ft. Cannot. Because you don't have informations about the force, you don't have informations about the time. What you do have is the initial and final velocity. Therefore, we are going to apply impulse momentum theorem, where J at the same time is equal to change in momentum. And what does it mean by change in momentum? Which is equals to mv final minus mu, okay, velocity final minus initial velocity. So now we can solve the question. So m is 0.2, v, okay, now v, final velocity. So final velocity, what do we have? We have a negative value. So make sure to include the negative sign in your calculation. So negative 70 minus m, which is 0.2, initial is 100. All right. So which is equals to, your final answer is equals to negative 34 ns, Newton second. Okay, Newton second. So this is the final answer. Now, why did I say it is very important to know whether the impulse is acting on the ball or on the wall? So if you have an object, the moment it is in contact with the wall, all right? So it's going to be like a Newton's third law. So this object will exert impulse on the wall. If ball exert impulse on the wall, then the directions of impulse is going to the right. So this is J on the wall. All right. So if you want to calculate the J on the ball, then you need to see, okay, the direction should be from wall to ball, because now wall is pushing the ball when the ball hits the wall. So both things happens at the same time. So if the question asks you to calculate J on ball, okay, J on the ball, then the J is going to the left, which is a negative value. So it makes sense, which means our answer is correct. Now, what should you do if the question is asking for impulse on the wall, and then you obtain negative 34 Newton second? All right. In this case, what you can do, all right, if you look at the diagram, because the impact is mutual, all right, the impact is mutual. Ball and wall, they both push each other at the same time with the same amount of force. Therefore, their impulse is the same. So J on the ball, all right, J on the ball is equals to negative J on the wall. So they have same magnitude but opposite sign. So if the question asks you to calculate J on the wall, then what are you going to get? J on the wall is just equals to positive 34 Newton second. Right? So just now we have J on the ball, which is a negative value. If the question asking for J on the wall, then it would be a positive value. So how do I know? It's based on the diagram. Okay, it is based on the diagram. So questions B, if the ball is in contact with the wall for 10, now this is things that I want to show you. Okay, just now I remember the wrong question. So this one, 10 ms. So this 10 ms, it doesn't mean 10 meters second. This m, it actually represent milli. Okay, this m represent milli because there's no space between them. If you have a value with a space between them, for example, you have 10 m and then space s, so this m is meter. Okay, this m is meter. But if there's no space in between them, then this m represent milli. So in your notes, actually, there's quite a lot of typo, all right, because they didn't put space in between meter and second. So it will make us confused. But don't worry, in exam, they will check and check and check again to make sure the space is there. All right, so you won't have this issue in your exam. So what I want you to know now is that if there is a space in between them, then this m represent meter. If there's no space in between them, then this m represent milli, right? So it can be applied to all prefix. Any prefix, if they stick together with another unit, then they act as prefix. If they split, okay, they are not joining with the other unit, then they might be another unit. They could be another unit. All right. So if the ball is in contact with the ball for 10 milliseconds, determines the magnitude of the force exerted by the wall on the ball. So again, you want to calculate on the ball. So J on the ball equals to Ft. Okay, so now you have a J which is equals to negative 34. You need to include the negative sign, which is equals to F is the things that we want to find, and then 10 milli. So 10 times 10 to the power of negative 3 second. Therefore, F is equals to negative 3,400 Newton. All right. So again, you have a negative value. So you rewrite it in a sentence form. So the force, the average force acting on the ball, okay, so you write that until at end, is 3,400 Newton to the left. Okay, to the left. So this question, the answer must be in a positive value. Why? Because question asking for magnitude. So if you leave the answer in the negative form, then you're going to get the wrong answer. It must be a positive value. Okay, it must be a positive value. So that's why I say it is always a good idea to rewrite the answer in a sentence form, so that you can get a positive value, which could represent some magnitude and which could also prevent the arguments in the answer, right? Prevents arguments in your answer. All right, so now I give you again, I give you 2 minutes to write it down, especially related to this diagram. Okay, what does it mean by impulse on the ball? What does it mean by impulse on the wall? Okay, it is very important. I think you're going to apply it in a question 6, if I'm not mistaken. All right, 2 minutes for you to write it down. All right, so any questions? Other questions. Very good. All right. Okay, wait, yeah. Now let's see. Next question. Next question is a very simple question. So a force of a 500 Newton is applied to a 1,200 kg truck for 5 seconds. What is the change in the velocity? So now let us list down the information that we have. We have force, which is F equals to 500 Newton. And then we have mass, which is equals to 1,200 kg. And then T equals to 5 seconds. Now it asks for the change in the velocity. How do we know which equations to use? So first of all, you need to know what does it mean by the change in velocity. So change in velocity is delta V. Delta V is actually equals to V minus U. Okay, so how do we obtain the delta V? Now, delta V actually can be found in our change in momentum. Okay, because change in momentum, it tells us that it is equals to mv minus mu. And when you factorize m out, you're going to get v minus u, which is then equals to m delta v. So this is where you can get delta v, which means you need delta p, the change in momentum, to solve the question. So when to use the change in momentum? Now you have F, you have T. It means we are going to apply impulse momentum theorem. So J equals to delta P and J equals to Ft. Delta P, according to my derivation just now, I have M delta V. So delta V is the things that I want. Therefore, delta V is equals to Ft over M, which is then equals to 2.08 ms negative 1. So this is how we solve questions number 6. So the key point is whether you know delta P is equals to M delta V, right? So you have a change in velocity, therefore you need a final minus initial. So where can you find the final minus initial? It can be found in a change in momentum. Okay, it can be found in a change in momentum. Alright, questions number 7. A tennis ball of mass m equals to 0.06 kg and v equals to 28 meter per second strikes a wall at 45 degree and rebounds with the same speed as shown in the figure below. So calculate the impulse given by the wall. So now you move these two vector in a Cartesian coordinate, x component, y component. So initial is the bottom one, final is the upper one. So I have initial velocity here, I have final velocity here, okay, v. So both of them, they are 45 meter per second, which is at the angle 45 degree above a x component, right? If even if you use the angle beside y also fine, because 45 degree is the same on the both side. So how are we going to calculate impulse? So in this case, we can calculate impulse by just using the x component. All right, so why just x component? Because y component, if you find a change in the momentum, then Vy and Uy would be equals to 0. Okay, Vy minus Uy equals to 0. So what are we going to do now? We just need x component. Okay, because both U and Y, they are both heading upwards. So if you want to find a change in momentum, they are going to be equals to 0. Therefore, what we're going to use, we use only x component.
Madam,
Yes?
yang V sebelah tu, sudah
Uh-huh.
dapat semua kan?
Apa? 45, yes, thank you. Okay.
Okay.
So, terima kasih. So, memang kadang-kala saya akan salah tulis nombor. Alright, Anda kena tengok-tengok and then tolong remind saya. Okay, now what do we want? We want the x component only. Therefore, J equals to delta P. Now, delta Px, right? And then equals to M Vx minus M Ux, which is then equals to 0.060 kg times, okay, Vx. Now I have V equals to 28 meter per second. But now if you look at my diagram, it is located in the negative x component. So negative 28 cos 45 degree minus 0.060, and u is also equals to 28 meter per second, but now it's located in the first quadrant. You have positive x. So positive 28 cos 45 degree. Therefore, total J is equals to negative 2.4 kg ms negative 1. So that is our final answer. So for these questions, you don't have to calculate the y component because both of them, they are heading upwards. Y component, they cancel with each other. Okay, so you need the x component only. So this is questions number 7 for you. Again, I give you 2 minutes to write it down. So again, this is a two-dimensional questions. Why involve a resolving vector. So remember, you always need to resolve it. So again, since it's a negative value, don't forget to rewrite it in the sentence form. So the impulse is, okay, the impulse given by the wall is 2.4 kg ms negative 1 to the left. Okay, to the left. right. So this is this is a very simple questions. As long as you know how to resolve it, which components to be resolved. Okay, jangan salah resolve sudah. So sometimes what happens in this type of questions, students resolve M and then they resolve V again. So it becomes we resolve the same component twice. Therefore, you're going to get the wrong answer. Right? So jangan confuse. You have to know which one is a scalar quantity, which one is a vector quantity. Okay, now let us look at exercise 2. Exercise 2 involves graph question. So let us do a quick revision. So far, how many types of graph have we learned in chapter 2? So in chapter 2, we have S against T. S against T, what is the information that we can get? Gradient. Okay, gradient give us velocity. And then the second type of the graph that we learn is V against T, which the gradient give us acceleration, and then the area give us a displacement or distance. Okay, now I'm just going to write symbol easier. Okay, so it gives us S. And then we learned about AT. Now AT actually area will give you V, but it doesn't give you any useful information. So usually we don't calculate it. Okay, because it could be positive V, could be negative V. It depends on the directions of the motion. Okay, so we have AT. And then in chapter 3, we have a new graph called FT. So this is the fourth graph that we have in our syllabus. So FT graph, what is the information that we can get? We don't look at the gradient, but we look at the area. So area gives us the information about impulse, J. So today, what are we going to see is FT, the area is equal to J. We want to find as much information as possible based on this equation, okay, by using this relationship. Now, it is very important for you to write this in your answer. Why? Because it's worth 1 mark. Okay, it's a marks for concept. So let's look at questions 1. Apply force against time graph of an object is given as shown in figure below. So you have a figures on the left hand side. Find the impulse of the object between 0 until 10 seconds. So basically, you need to calculate the area of the whole graph. So the first sentence that you should write is area under FT graph. Okay, area under FT graph, it is equals to impulse. So this statement itself, it gives you 1 mark in your exam because it represents concept. So this is your K1. It means that you understand the concept. You know which part represent impulse. You know how to find impulse based on FT graph. All right. And then impulse equals to, okay, area under the graph. You have a trapezium here. So 1/2 bracket. The base is a 10. Okay, it's 10 plus. Now the upper line you need to subtract. Okay, 6 minus 2. And then times the height, which is 20. So which is equals to 140 kg ms -1. So usually the equations for area give you another 1 mark. Final answer give you another 1 mark. Okay, final answer with correct unit. So this question itself seems very simple, but it worth 3 marks in your exam. So again, like I told you previously, if you don't know how to use the equations for trapezium, you can always split into 3 parts. Calculate area 1, area 2, area 3. Okay, then you can calculate J by using area 1 plus area 2 plus area 3, okay, which is correct as well. So in exam, it is up to you which method to be used. As long as you can get a correct answer, then that is a correct method. Okay, then that is correct method. So now let's look at the questions 2. Questions 2, again, you have F against D. But questions 2 is a questions where students often make mistake in their exam. Why? Because you guys always forgot about the unit. Now you look at the unit given in the graph. F is now in a K kilonewton. Time is in M, which is millisecond. Right? So calculate the impulse delivered to the board. So impulse, we know it is area under the graph. So now we have triangle. So again, area, you need to write it. Always need to write it. Area under FT graph is equals to the impulse, right? Is equals to impulse. So impulse is then equals to 1/2 times the base, okay, the base of the triangle. So what do we have now? We have a 1.8 minus 0.2 times 10 to the power of negative 3, and then times the height, which is 18 times 10 to the power of 3. Therefore, the final answer is 14.4 Newton second. Okay, 14.4 Newton second. So this is the answer. Okay, this is the answer. Now, when it comes to the graph questions, you cannot state the direction, right? Therefore, you just leave it. And of course, actually, it's a positive direction. Okay, because you have a positive impulse. So if you have a negative area, then the impulse is negative. Then you know it's going to the left. So in this case, if you want, okay, you can also state lah if you want to the right. Okay, to the right. Actually, it can go up as it can go up as well, but now you have a tennis ball, so it's either left or right. So the speed of the ball after being struck, calculate the speed of the ball after it's being struck, assuming the ball is being served so that it's nearly at rest initially. So it wants you to find the final speed, right? It wants you to find the final speed, and it tells you initially it is at rest. So U is equals to 0. So by applying J equals to delta P, okay, J equals to delta P, so it is equals to mv minus mu. Okay, mv minus mu. Therefore, J we have 14.4 equals to m we have 60 gram. Now this 60 gram must be converted into kg. Why? Because our unit for impulse is in SI unit. Okay, so the rest of the unit, the rest of the variable, they must be in a SI unit as well. So m 0.06 kg. Okay, 0.06 kg times with the v. So v is the variables that we want to find, minus 0. So how do I know 0? Because my u is equals to 0. Therefore, v is equals to 240 meter per second. Okay, so 240 meter per second is the final speed. It's the speed when it strikes the ball. Okay, so this is your questions number 2. Okay, questions number 2. So I give you 1 minute to write it down before we proceed to the next question. Next questions, I will just tell you how to do it, so you solve it by yourself. All right, the following 2 questions, you tried it. So I will tell you how to do it, and then you tried it. Okay, next. So this questions 3 and questions 4, actually they are similar to questions number 2. The only difference is now you yourself have to know, you need to determine the impulse from the graph first. The questions didn't tell you what to do. Okay, so questions 2 is a guided question where we consider that as a basic question. Questions 3, this is what we call hot question. Okay, means that you have to think what to do before you can find the final velocity. So now let us go through the question. Paul and Nick push a fuse broken down car down the road. At times t equals to 0, they push it with a force 1000 Newton. So your graph begins from 1000 at times t equals to 0. They reduce their force gradually to 500 Newton at times t equals to 5. So they decrease the force gradually, slowly, and at times t equals to 5 seconds, the force is now 500 Newton. And then they continue pushing it with a constant force for another 5 seconds. Okay, therefore you have a horizontal line in the graph for another 5 seconds. If the car is 1000 kg, so m is 1500 kg, so m is 1500 kg, and it start from rest. Again, you have the term from rest. It tells you your u is equals to 0 meter per second. So question is asking for v. Now, if you look at this question, you don't have enough information to solve it, right? But what you can do is that you can calculate impulse from the graph, because now you have an FT graph. So whenever you have FT graph, remember the information that you can have is impulse. So if you have impulse, you have initial velocity, you have a mass, can you find the final velocity? Yes, you can. By applying J equals to mv minus mu. All right, so this is the things that you need to think of. You need to know that you need to calculate impulse from the graph. And that makes this question a hot question. Okay, because you have to think of one step before you can calculate the final answer. Okay, there is a hidden step before you can get the final answer. All right, so questions 3 and questions 4, they are the same. So I will leave it to you. These two questions, you answer it on your own. If you have any questions, you ask in the next lesson. All right, so questions 4, you have a negative impulse. So remember to put a negative sign in your impulse. So positive J, negative J. So you solve it by yourself. If you have any questions, you ask on a Friday. So tomorrow we'll be discussing graph questions, your lab report. So make sure you enter tomorrow class with data, all right, with your complete table. So I think that's all for today. Okay, if no questions, then you may leave the class.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.
Thank you, madam.
All right.